So this is our first problem on the mock test for chapter 2. Our test is Friday, 9:30, right? Not 9:30 in the morning, September 30th. Here's our problem. And you see I like to just shortcut this function with a star or some other symbol so I don't have to keep writing limit. So my first sentence is I'm trying to find that limit, right? So then I am working on that function, trying to find the replacement function. I find it easier to get rid of fractions first before I try a conjugate, right? And so I use 2 square roots of x as my LCD. I multiply the numerator by that and the denominator by it. The denominator is the one that has purpose. That's the one that's going to clear fractions. So I don't want to distribute anything if I don't have to. So I multiply 2 rad x times quantity square root of x minus 2. And then downstairs, I skipped a step here. 2 rad x over 2, right, minus 2 rad x over rad x gives me my rad x minus 2 again. So that cancels, right? And it turns out there's my replacement function. Pretty damn simple. 2 square roots of x is the replacement function. Then I go back to my limit, right? So now I'm reminding that I have star. I'm doing the limit as x goes to 4 of that replacement function. I plug it in. Notice when I plug it in, I'm no longer writing limit. I already know the height. The height is 2 square roots of 4, right? I'm not asking what's the height anymore. I know the height. But of course it can be simplified, so we get 4. How many of you got the 4? Beautiful. That's great. So you know you got 10 points at least on the test. And you've probably already checked it on Desmos. I would do it numerically right away, just to know what I should be getting. And it might give me a hint at what I have to do, right? The second problem, it's still listed as number 1 on the test, but it's 2 problems to do that same limit using L'Hopital's rule. So L'Hopital's rule says if I do a limit and get 0 over 0, that's an indeterminate form, I can use I can replace the numerator with the derivative of the numerator and replace the denominator with the derivative of the denominator. So notice what I'm doing. I'm rewriting my limit, but I've got my numerator wrapped in parentheses with the placeholder of prime, right? Meaning take that derivative. And of course, we know the derivative of square root of x is 1 over 2 square roots of x, and the derivative of 2 is 0, right? The downstairs is a little bit trickier. So as I'm rewriting it from here to here, right, I'm rewriting it as a power rule so that I see that I have 1/2 minus x to the minus 1/2, right? But again, I have to take that derivative. And when I take that derivative, the exponent goes down. So I get the 1/2 out front, double negative cancels, and I subtract 1 from the exponent. So minus 1/2 minus 1 is minus 3/2. Is everybody with me there on this step, on box? Minus 3/2? Yeah. I've got minus x to the minus 1/2, right? So y prime is bring down the exponent and reduce the exponent by 1. So I get positive 1/2 x to the minus 3/2. That's right. That's right. That's right. That's right. Yep. So now, and I could just plug in the 4 now, right? But I personally, I want it to look a little bit nicer, so I figure I'll do some algebra. So I see my 1/2s cancel. The rad x is in the denominator, so it moves to the numerator as x to the minus 1/2. The x to the minus 3/2 is in the denominator. It moves to the numerator as a positive x to the positive 3/2. So 3/2 minus 1/2 is 2/2. So there's x to the 2/2, which is just x. And I just plug in the 4, and I got it. Done. How many of you got the L'Hopital's? Beautiful. Beautiful. Your first question on the test is almost identical, okay? Nice. Let's go to number 2 on our test. We're finding the derivative using a limit, and then we're going to verify that with the power rule, which is real simple, right? So let me give you 15 minutes. Go. Remember, we have 2 things for the Monday. So moving both upstairs. So the square root of x plus minus x to the minus 3x plus x to the 3x. Square root of x moves upstairs, x to the minus 3x. X to the minus 3x moves upstairs, x to the 3x. And then multiply by 3. But I recorded the answer for number 1. I forgot to stop my recording. Did record the solution to number 1 if you came in late. Okay, so number 2, it's when I read the question, I'm going to say, well, what do I want to do first? I want to do the power rule first. It's easy, right? So I got my function written as x to a power, right? I have x squared minus x to the negative 1. So when I do my derivative, I get 2x. The negatives cancel, and then I get x to the minus 2. So that's 2x plus 1 over x squared. And then I get an LCD, right? I get an LCD. Remember that when I have more than one fraction in my solution or my derivative, I want to get rid of it. I want to get a single fraction completely factored. So obviously I need an x squared in that first term. Oops, x squared, right? So upstairs I get 2x cubed plus 1, and downstairs is the x squared. How many of you got the power rule? And you factored it? Yes. So you got to get it as a single fraction. Only 3 of you. 3 of you. 4. 5. Nice. And I told you already, this test is more difficult than your test. Okay? I like to do that. Well, one is sometimes I can't help it. When I just think of problems right off the top of my head, I don't realize how easy or difficult they are. They usually tend to be difficult. So, but now we're doing this problem, and we've never done one like this, David. Oh, we've never done one like this where I have a single, right? I have a single term and a fraction. So definitely tough. So, but I first plug in my original function with x plus h, right? Minus the original function all over h, right? And so that piece is my star. I want to get a replacement function. Right now, if I let h be 0, I'm in trouble, right? What do I get if I let h be 0? I get 0 over 0, right? So I know I have to find my replacement function. So I've got my function here. I tried to not do too much. I don't want to expand if I don't have to, okay? I don't want to distribute if I don't have to. I want to see what I can do without doing that first. So, but I do notice I have two interior denominators, x and x plus h. So that's what I use over itself to at least clear interior fractions. All right, so what happens when I do that? The first one, nothing cancels, so I get an x times an x plus h cubed. Everybody with me there? In the second one, the x plus h's cancel, so I just get the negative x, right? In the next one, I get x cubed times x plus h, and in the last one, the x's cancel, so I just get the x plus h. If you remember, I said if there's some pieces without a factor of h in it, right, they had better go away. And you can clearly see that my two x's here cancel. I'm not trying to do too much. I did something in my head, and that's probably where I made my mistake. But I'm going to factor out an x and an x plus h from these terms. Take a look. There's an x and an x plus h there. There's an x and an x plus h there. Yes, do you see it? So I factored out that x and x plus h. I have an x plus h quantity squared left, and I have an x squared left. Of course, I still have this leftover h. So then what did I do from here to here? I expanded this x plus h quantity squared to get x squared plus 2hx plus h squared. And again, my x squared terms canceled there. Trying to rewrite, trying not to do too much. I've got x times x plus h times 2x plus h squared, right? And then plus another h. So I just rewrote, right? Do you see it? X plus h, 2hx plus h squared, plus another h. Kind of weird here that I am factoring only two terms of it. And like I said, this is a tough problem. The one on your test is easier. So notice I can factor out an h from both of those terms, and out it comes here. Oh, there it is. I lost my x somehow. Do you see? I lost my x. So there's an hx there. Nice. So take a look at that. What now can I factor from every term is an h, right? I can factor out this h, and this h, right? So upstairs is my factor of h, downstairs is my factor of h, and I still have an x out here. That was my mistake. So now I finally have my replacement function star, and you can see now I can, yes, do it. What? Yes, I'm right here now. I'm right here above that line. Just let me finish, okay? So I've got my replacement. You're right. I need that other x. Yes. So I've got my replacement function star. I'm now going to take the limit of star as h goes to 0. So I plugged in every h here as 0. This is h is 0 now, so that's just an x. This h is 0, so that's just a 2x. This h is 0, so that's an x times x downstairs. So what do I have now here? I've got 2x cubed. Yep. Plus 1 over x squared, same as my power rule. Question? Yes. You did the super expanded version. You just foiled everything out. Yes. It's not wrong. It's not wrong to do it that way. It's just, I mean, this problem is horrible no matter how you do it, right? The one on your test is easier. I promise. Question? Yep. Power rule just says x to some power, right? Bring down the power, reduce the power. Right? Yes. Yes. I'll probably give you 9 out of 10 or something. It won't stop you from getting your A, but it will stop you from earning. If you get 100 on any of my tests, I used to give $100 to a student to get 100, but my Monopoly game is like ruined now. What I give now is a 4-color nerd pen. You know, the Click 4-color pen. If you get 100 on the test, I give you the pen. Brand new. All right, here we go. Stop the recording. This yet? Of course, you should check. Remember, on your test, I'm expecting you to check everything. I didn't put a product rule in the test, but I did put a quotient rule in the test. Okay? But it's still, if I think it's too tough for you to do, I'll just give you the slope, the derivative. But this one is not bad at all. So here's my function, sine x times cos x. I see I need a product rule. First function is sine, derivative is cosine. Second function is cosine, derivative is negative sine. And then I multiplied this one first, because when it's a product rule, it doesn't matter. You're adding the two. So a plus b is b plus a. So I got cos squared minus sine squared, which is an identity cos of 2x. Now, if you didn't know the identity, fine, right? But you certainly could still use this piece to get the slope. So what am I doing next? So how many of you got cos squared x minus sine squared x? Beautiful. For the derivative. Yeah, good. So I have my x minus pi over 3. I find my y going into the original function. I get square root of 3 over 4. Oops. Oh, I get negative square root of 3 over 4, right? So I made a mistake in the rest of my problem, but that's okay. Negative square root of 3 over 4. And now I'm finding my slope. I'm putting it into cos of 2x. So I get cos of negative 2 pi over 3. Negative 2 pi over 3 is in this quadrant, and of course cosine is negative there. So I'm doing a negative cos of the reference angle, pi over 3, so that's negative 1/2. The slope. So I've got my, I just made one mistake here, so that's a negative. Everything else is right. So I got my y value, I got my m value, I got my x value, right? So I'm working on my my tangent line now. And of course the calculus is done, right? At this point the calculus is done. So not much to do here at all. I just got one little sign error. This is a negative out here, and this is a plus in here. And then, of course, you're checking it on Desmos, right? Yeah. Okay, we're running out of time. We got to move on. You need to be conscious of the time during the test. I will tell you when there's 25 minutes left, right? I'll tell you when there's 10 minutes left. But you have to be conscious of how much time you're spending on a problem. If you spend 20 minutes on one problem, you're not going to finish the test. So if you're stuck on a problem, listen to me, please. If you're stuck on a problem, you go finish the rest of the test, and then you go back to that problem. Don't keep spinning your wheels on something, right? Finish the rest of the test, and then go back to it. All right, here we go. Number 4, find the continuity. Find A and B. I'll just record the actual answer there. All right, so we're ready for Friday. So the original function was AX plus B. So the derivative is
that's right. That's one. That's right. Okay.
All right, have a appreciate you Friday.